On January 23rd, a family in China traveled from Wuhan to the city of Guangzhou. The next day, they ate lunch at a restaurant. One of them had COVID-19, but didn't feel sick yet. Within a few days, other members of the family started showing symptoms. And a few days after that, so did the family who was sitting at the table next to them. The family at this table also got sick. And researchers say this first person was the source of all these infections, even though some of them were sitting almost 14 feet away. But the people eating at these tables didn't get sick. Why? An air conditioning unit right here kept the air flowing through this section of the restaurant. It circulated the virus from this person through the air to these other families. The story highlights something about the coronavirus most of us are just starting to understand.
Particles that are bigger than 5 microns tend to settle, meaning fall down on surfaces such as the floor, and they fall fairly close to the source, typically within 6 feet. This is why the CDC recommends 6 feet for social distancing. But here's the thing. Sometimes these larger particles travel farther than that, especially if someone is breathing heavy, or shouting, or singing, or coughing or sneezing. Typically, they fly no further than 12 feet in these situations. But we're also spraying particles that are smaller than 5 microns. And this is why these tiny particles, they don't act like ballistics. They act more like a gas cloud where they float in the air and travel up to 27 feet. The ones that are less than 1 micron evaporate within milliseconds of hitting the air, while the particles that are more than 100 microns can take up to a minute to evaporate. So what happens when the droplets that are less than 5 microns, what if they're spewed from someone who is infected with the virus and all of a sudden in midair, they evaporate? Well, they dry out and you're left with a virus that is floating in the air. These are called droplet nuclei, aka aerosols. There are lots of factors that determine how long aerosols remain in the air. Just like there are a lot of factors that determine how long a fart will stink up a room. It depends on the person who emitted the particles, how they emitted them, the temperature and humidity of the environment. Now let's take a look at what happens when someone sneezes. This was published in the JAMA article, and they took a super slow motion video of a healthy person sneezing. You can see the varying degrees of droplet sizes. The larger ones fall to the floor like ballistics, but the tiny ones remain airborne in this wet cloud, if you will. Not only does this wet cloud help keep the virus viable for a longer duration, but this cloud can travel about 23 to 27 feet depending on the conditions. Lack of airflow means that this cloud will persist longer, and when this moist cloud, they use tracers to visualize the cough in the cloud that forms as a result of the cough. It showed that the cough expelled the gas up to 12 feet in a span of 50 seconds. After that, they covered the dummy's face with different types of face coverings. So without a face covering, the average jet distance was 8 feet and the maximum was 12 feet. With a bandana made out of elastic t-shirt material, the average distance went down to about 3.5 feet. With a folded handkerchief that was made out of cotton, it was about 1 foot 3 inches. And with a stitched mask that was made out of quilted cotton, it was about 2.5 inches. And with a commercial mask, specifically a CVS cone face mask, it was 8 inches. And with this medical mask or surgical mask, you could assume it's going to be about 8 inches. Now, mind you, in this study, the tests assume that the mask is properly worn and not saturated with water or sweat, which can affect the distance of the jet propulsion. So these types of masks are good at helping to mitigate the spread of the virus to other people. Are they perfect at doing so? Absolutely not, but they do make a big difference. What they don't do is prevent you from inhaling the virus, because where there's openings, that's where the air gets sucked in, and that's where you can inhale it. But if you have an N95 respirator mask or an elastomeric respirator, then your chances of inhaling that virus go down dramatically. N95 respirators are tight-fitting and filter out at least 95% of airborne particles as small as 0.3 microns.